Hello friends, welcome to our channel. Today the topic is multiplexers. Okay, today we will discuss regarding on multiplexers. So, how to define or what is the definition of a multiplexers? Multiplexers is a combinational circuit. Actually, it is a combinational circuit that receives binary information from one of the 2 to the power input. Okay, 2 to the power n input data lines, and directly it will provide that is a single output line. One line with one output we can get it. That means we have to provide 2 to the power n inputs, but only one output we can get. That is the basic concept of multiplexer. Okay, when we will get that output, how to get? Since we are providing for any number of or 2 to the power n input, which input consider as a output? Okay, that is the one approach or some techniques is there by which we can get one output where 2 to the power n input we will provide. If we compare to encoder, then what happens? We can also consider 2 to the power n inputs, but we will get n output. Okay, previous lectures also I also mentioned. That means 2 to the power n inputs we will give, but we will get only 2 to the only n output. 2 to the power n inputs we will get only n output for encoder. But similarly, if we go through multiplexers, similarly 2 to the power n n inputs we will provide to the multiplexers, but we will get only one output. This is the basic concept or difference between multiplexers and encoders. Okay, but in this case, if we go through multiplexers, one approaches some techniques, some logic is there. They will select which input consider as one output. Some techniques is there, and some selectors is there, that selectors select one input which is considered for output. That is decided by one selector. We can tell as that is selection lines. Also we can consider as a selection lines who collect or who receive the input, and that input consider as a output. Okay, so and another concept also we can define, that is multiplexer also often called as a data selectors. Because why it is data selectors? Because it selects only one of many data inputs. Okay, so other name also we can tell as a multiplexers, other name we can tell as a data selectors, because it selects only one of many inputs. We can give it many inputs, but it will select only one inputs. Okay, and it will provide that inputs as a output. Okay, so now different design of multiplexer we will consider. So basic concept we will define like suppose 2 to the power n inputs. Okay, 2 to the power n inputs we will provide. It will if you will give to the particular multiplexers, it will give only one output, only one output. Okay, that means 2 to the power n inputs we will give to the multiplexers, but it will that is providing only one output. This is the basic concept. Another is whenever you design that multiplexers, depend on the what kind of multiplexer we have to design. Okay, previous case that's like encoder or decoder, different names we can tell as. Okay, just suppose decoder, that means 2 to 4 decoder, 3 to 8 decoder. If you go through encoder, similarly reverse case, 4 to 2 encoder, 8 to 3 encoder. Okay, different name we can design, we can call as. Okay, that decoder or encoder. Similarly, if we go through multiplexers, okay, then we can also name what kind of multiplexers. Okay, type of multiplexer, what kind of a model of a multiplexers? We can tell as a, it is a model of multiplexers. For example, suppose n is equal to 2, then 2 to the power 2 is 4. Okay, that means 4 inputs we will provide. Whenever 4 inputs provide to the multiplexer, then what happens? It will release only one output. Okay, it will release only one output because all multiplexers provide only one output. What are the many inputs we will give to the multiplexer, but the multiplexers provide only one output. Okay, if we go through this kind of model, means 4 inputs and one output, we can tell as a 4 into 1 multiplexers. Okay, we can tell as a 4 into 1 multiplexers. This is the basic concept. Okay, so different model of multiplexers also we can consider. Similarly, if we go through n is equal to 3, then 2 to the power 3 is equal to 8. So it also provide one output. Okay, it also provide one output. So this model, if we go through a multiplexer with this model, then we can tell as a model is a 8-1 multiplexer. Okay, 8-1 multiplexers. So in this way, different multiplexers we can design. Which kind of model is required of us, then we can design accordingly. Okay, different multiplexer also we can design. Now we see that basic block diagram of multiplexers. What is the basic block diagram of multiplexers? Okay, very simple basic diagram we will consider. You see, suppose we will consider 4 into 1 multiplexers. Like we will design 4 into 1 multiplexer. Okay, now we design 4 into 1 multiplexer. Then how to design? Very simple way. We will consider this multiplexer. Like I told that multiplexer is what? It is a combinational circuit. Inside is some circuits is there, but it is a combinational circuit. Means a collection of circuits to make a particular block diagram. So just a block diagram we will create through this 4 into 1 multiplexer. Very simple way we will consider like a 4 into 1 multiplexer in this way. Okay, 4 into 1 multiplexer. Then how many number of inputs will provide to this multiplexer? You see, very simple. How many? 4 inputs. Okay, so 4 inputs will give to this multiplexers. So inputs are defined like a I0, here is I1, I2, I3. Okay, 4 multiplexers we will consider. That 4 multiplexers, whenever that is 4 inputs, 4 inputs considered for this multiplexer, it will release only one output. Okay, it will release only one output. And whenever one output will consider that is y as a one output, how this output will get? Means it will receive either I0, I1 or I2 or I3, any which data it will receive, by which y can consider as a particular value, which is depend on these 4 inputs. Okay, we can tell actually which data will consider, because that is connected to this particular multiplexer. But which data will receive and it will consider as a output, we don't know. So to avoid such kind of difficulties, we consider some selection operation. Okay, that selection decision selector decide which inputs consider as a output. The 2 selectors we will consider here. One is here 2 selectors also we can define here. Then we can understand how these 2 selectors define that is a or decide which inputs consider as a output. S0, S1, two selectors will consider. These two selectors, it is one kind of technique or approaches that two selectors decide which input is considered as a output for Y. Okay, this is the basic diagram. We will discuss how it will receive, how it will consider this particular output. Whenever this multiplexer receive the data I0 to I3 and which data consider as a output for Y, that we will discuss. Okay, now this is the basic diagram. We will consider this basic diagram. Now we see, whenever we go through this basic diagram, then what happens? Again, we can also define the truth table from this basic diagram. We can tell as this is block diagram of multiplexers. We can write a block diagram of 4 into 1 multiplexer. 4 into 1 multiplexer. We can tell in this way, no problem. Okay. Now we see, we can define this multiplexer in this, from this multiplexer we can define the that is a truth table from this multiplexer. How to truth table from this multiplexer we define, then we will see. Other name also we can tell as a function table for 4-1 multiplexers. Now we see function table for 4-1 multiplexer. Okay, now we see how to define 4-1 multiplexer. Okay, let us consider define the function table. Function table is defined in this way. You see, first one, you see, just draw this one S1. Do this, we can tell as a function table for 4 into 1 multiplexer. Okay, function table for multiplexer. So I told, whenever we will provide different inputs to the multiplexer, then which multiplexer will release as a output, or which inputs consider as a output is decided by two selectors. That selector will decide. Okay, that is one kind of technique is there. Selector will decide which inputs considered for the multiplexer, and that inputs also consider as a output. Selectors will decide. So here you see, very simple way, S1 and S0. Previously that block diagram we have already done. Then we can find out how these multiplexers provide or create this function table as per the block diagram. We will see. Now since it is a two selectors and that selectors also define that is a how to two selectors, why not a three selectors, we will discuss later. First of all, we will draw this particular function table as per this block diagram of multiplexers. Okay. Now see, since it is a two selectors we will consider, then two selectors defined through binary form like 0 0, okay, 0 0. Next, here is a, that is a 1, it is 0. And that trick also all of you know that. If not, then you can see that how it is coming. 0 1, here is a 1 0, here is a 1 1. Because this is the basic binary form of two selectors. First one we will consider 0 0, next is a 0 1, next is a 1 0, next is a 1 1. Okay. If we go through 0 0, S0 is 0, S1 is 0, then what happens? The output we can get from I0. If is 0 0, the output we can get from I0, because you see very simple way I will mention here. You see, S0 if 0 0, then I0 consider as input which is provide the output for Y. Similarly, if this is 0 1, okay, then we will consider I1. Different format also I will show you. You see, very simple way. This is I0. Again S0 is 1, S1 is 0. Okay, then we can consider as I1. Then if it is 1 0, we can consider as I2. Here if 1 and both 1 1, we will consider as I3. Okay, so different results for Y we can consider in this way. So that means 0 0 I0, 0 1 I1, 0 2 sorry 1 0 I2, 1 1 I3. So very simple way, all of you know that this part particularly if we go through that part, then we can see how it is defined and how it is used. Okay, like you see this part is 0, okay, this part will be 1, this is 2, this is 3. Very simple way we can define. So whenever define in this manner, then what happens, we can also consider this 0 1 2 3 as input. 0 I0, 1 I1, 2 I2, 3 I3. Okay, this is the decimal number. Decimal number also defined through this binary form, that is 0 0 is 0, 0 1 is 1, 1 0 is 2, 1 1 is 3. So in this binary form also this decimal number, this binary form create a decimal number like this. That decimal number also consider for this output based on this input, like 0 is I0, 1 is I1, 2 is I2, 3 is I3. In this way we can get this kind of input data which is provide the output for this Y. Okay, this is the basic concept whenever you go through function table for 4-1 multiplexer. Okay, now we see this is the function table. Now also we can define for the Boolean function. Okay, we can also define for the Boolean function where the two selectors will consider as input and Y also consider as output. Okay, and this output is defined through I0, I1, I2, I3 like this. So very simple way I will describe the Boolean function for this output Y for 4-1 multiplexers. Very simple way I will design. You see, whenever I go through Y is a suppose consider as a Boolean function. Okay, Y is a consider as a Boolean function. Then that Boolean function define which is defined through I0, but I0 depend on what? S0 and S1. Yes or no? I0 actually depend on S0 and S1. So both combination of this I0, S0, S1, the to make one logic circuit to make this value. Again Y also define I1, I2, I3 like this, which is depend on this S0 and S1. So the different logic circuits, logic gates we use for this multiplication whenever we analyze that Boolean function. Also we can write here Boolean function. Okay, Boolean function we can also write Boolean function. Very simple way we can use the Boolean function. You see, whenever I go through Y, this one first you see Y, it is depend on this one. S0 is 0, S1 is 1. Then what happens? And also combined with a Y, sorry I0. S0 is 0. We can consider as a S0. You see, since S0 is 0, 0 is the complement of 1. So obviously we can consider this is a complement. Okay. Similarly, another S1 is 0. Okay. We can also consider this is the complement of S1 1 dash or complement you can write. and this combined with the I0. We can write this is I0. Okay, this is one part, because y part is not only this part, it is combined with all. Whenever we will create Boolean function for y, y is the output. That output how to define through Boolean function, we will see. Now see other part also there. How it is 1. 1 means S0 is 1. S1 is that is a complement, because it is 0. So we can write S1 is that is a complement. It is complement. S0 is 1, means no complement is there. Then what is the output? That is I1. It is I1. Okay, this one concept. Plus, again plus. Okay, we can also write also there, here also we can write here. Another is here is S0 is 0, means S0 is complement. S1 is no complement, it is 1. So we can write S1 no without complement, and S0 that is a complement. Okay, and I2 here is I2. Okay, plus here is a third. S0 is 1, S1 is 1. So S1 is 1, S0 is also 1. Here is I3. Okay, here is I3. So in this way we can see how Boolean function can create in this particular, from this particular function table. Function table is given as per this block diagram of multiplexers. Okay, multiplexers we have already discussed. So from that multiplexers, how function table created, we have already discussed. But from that function table, how Boolean function is created, we will see that. Okay, so very simple way. This is the y part. Y part means what are the y value we will consider, they depend on the S0 and S1. So very simple way, once again, it is y is a design, it depend on this all value I0, I1, I2, I3, and it is combination of S0 and S1. Okay, so combination of S1 S0, here you see S0 is 0, means S0 dash, S0 dash, S0 is S1 is 0, so S1 dash or a complement, and it is I0. This is one part, this is a one part. That means whenever we define this particular that is Boolean function, then we see how it is defined, this particular Boolean function. It depends on that. So similarly, another part, it is I, here is S0 is 1, means no complement, S1 is complement, very simple. S0 no complement, S1 is complement, and is combined with I1. So like this different part we have to define here. Okay, but you see here some basic concept we will consider. Here the combination of I0, S0, S1 with some complement, but which logic gets used for this particular term, which particular or express term we use for this particular term, means I0, S0 dash and S1 complement. Here you see the multiplication of all terms I0, S0 dash, S1 dash. So we go through, that is AND gate, because it is mentioned what, multiplication of these all items. Here similarly multiplication of all items I1, S0, S1 complement. So here also similarly, how many, that is AND gate will consider. Why will we consider AND gate? Because this is the multiplication of all terms, all items. Similarly, how many AND gate will consider? Here is 1, okay, here is 2, here is 3, here is 4. 4 AND gate is required to design the logic circuit for y function or a Boolean function. Okay, but 4, that is AND gate is required. 4 AND gate, you see, we will consider, that is 4 AND gate. 4 AND gate okay, 4 AND gate is required. But again, what happens, since it is a 4 AND gate, but after that what happens, here also since in between this AND gate, one operator, the addition operator also there, 1, 2, 3, but this is one OR gate also we can consider to use this 4 AND gate, doesn't matter, okay, because 3 operator is there, plus here is plus, here is plus, plus, but one OR gate will consider what are the data, this is part 1, part 2, part 3, part 4, those part combined with a OR gate, okay, we can consider in this manner. Now we will see how it is designed for this particular logic circuit or circuit diagram for this Boolean function, okay. Now we see how it is how it will be designed for the logic circuit diagram or circuit diagram for this particular Boolean function. You see, very simple, the Boolean function is defined here, but we have to design logic or a circuit diagram of this particular Boolean function, okay. Just a minute, I will show you, okay. Now see, so how many AND gate is required? That is 4 AND gate, 4 AND gates are required. So we will draw very simple way, 4 AND gates, very simple way, we will draw this one, okay. Now see, here there is a 4 AND gate, okay. So 4 AND gate, we will draw it, okay, 4 AND gate, and whenever you go through 4 AND gate, then what happens, each AND gate, you see, very simple way it is mentioned, these 4 AND gate, here you see that is each AND gate having I0, I1, I2, I3, okay, that inputs also there. So each AND gate contains this I0, I1, I2, I3. So I will just draw one that is data to that AND gate, I0 here, I1 here, I2 here, I3, okay, this one. And another is other part, other inputs also consider as, you see, very simple, it is considered as what, S0, S1, okay. Sometimes S0 complement and S1 complement, but we have to consider two input, S0 and S1. Now we see how it is I will consider, okay. So we draw that is S1, and S0, okay. So one part, if I3 part is there, you see different ways also we can consider, okay. One here also you see another concept also we define here, after creating this different terms, lastly it combined with a, that is a OR operator, OR operator, or AND, or sorry, OR gate, here OR gate, here OR gate, here OR gate, that is 4 terms combined with a OR gate. So first of all you see one OR gate will take, okay, this OR gate will take all output will come with a OR gate, okay. And one output, that is a Y output, okay. This is the, that is a AND gate, and term not completed actually, one data given to AND gate, but output of this 4 AND gate, that is considered as input to the this OR gate. Y we will consider in this way. Now we will find out or we will consider this data S0 and S1, okay. Very simple way, if we go through, this is I3, you see that what are the data for I3, okay. What are the data? I3 part is S0, S1 without complement. S0 and S1 without complement. Then what happens? Very simple way. We just go through this S0 and sorry S1. Here is S0, here is S1. We will consider directly to this particular this AND gate. Okay. Next, where I2 is there, you see I2 is there, here I2 is there, S0 complement means see what are the S0 data, just a complement data we will consider, but S1 is as it is. Okay. Now I2 data here, S0 is a complement. Complement means we just draw one kind of concept here, just one inverter we just put it. Okay, one inverter. Then another inverter also we collect from like this. Very simply, whenever it is necessary, one inverter we can consider. After that, we will see that how data will receive from S0 to S1. But you see, very simple way, here what happens? That is S to I2 part, S0 complement S1, simple S1. So S0 complement means we can consider in this way. This is S0. S0 here is a complement. Okay. This complement consider in this manner. Another is S1, simple S1. Whenever S1, it will come like this. Very simply, it will come like this. S1. S1 and S0 complement. And similarly, whenever go through, that is a I1. Okay. Here I1, you see I1, that is S0. Simple, without complement. S1 is complement. S1 complement, you see, S1 complement and S0 simple, I1. Here I1, S0 simple. So S0 simple means, you see, another, that is here. Here also we will consider this for this one. S0. S0 means like this. Okay. Here also consider in this way S0 and that is I1, that is S1 complement. S1 complement, S1 complement means here S1 complement. So here S1 complement draw in this way. Okay, S1 complement. This is a S1 complement. This is a S0, simple S0. Next, last part we can see. Last part is I0, S1 complement, S0 complement and S1 complement. Both are complement. Then what happens? Here complement is coming here and S0 is complement. Here is S1 complement. So now you see, whenever go through this S0 complement, here S0 complement. Here you see S0 complement. So S0 complement first join here and here S1 complement again join here. Okay, this is the S0 and S1. So now we confirm, that is how this AND gate consider or receive the data either S0, S1 or with complement with I0, I1, I2, I3 of individual this data. Okay, whenever it will receive this four AND gate receive the data, then what happens? It will release the data, one output release to the data which is considered as, that is 4 input to the OR gate, because we have already discussed it has 4 output. Okay, sorry, one output which depend on this one we have already discussed. Okay, the block diagram of this is defined on this particular Boolean function. This Boolean function we have to define. Okay, we have to we have to create it. After creating this Boolean function, then we have to design this block diagram of that corresponding that multiplexers. So here is a circuit, that is a logical circuit. Okay, circuit diagram we can write. Circuit diagram of, or a circuit diagram of Boolean function. Boolean function, and that Boolean function also we can define from that function table, and that function table also defined from that multiplexers. Okay, in this way different stages are there, which part is needed, then we have to define accordingly. Okay, I think all of you understand how to define circuit diagram of Boolean function, and a Boolean function which is derived from function table. Boolean function derived from function table, which is derived from multiplexers. Okay, this is the basic concept. So we have to find out, we have to design multiplexers, or we have to design function table of multiplexers, or we have to design circuit diagram from Boolean function which is designed from function table or multiplexers. These are one after one dependent, that is tags. So as per the questions we have to define or design accordingly. Okay, I think all of you understand this particular topic, that is multiplexers. This is the basic concept I explained. So all of you understand. I hope you watch this videos very that is convenient way, and which is very understandable. So if this video is helpful to you, please comment it and share it, and also subscribe my channel. Thank you very much to watch my videos. Okay, thanks.